Question 6.40. The question saying that determine the force in member JE and GF of the truss and state if their member are in tension or compression. Also, we must indicate all zero force member. Okay, from the picture we know that the distance between AH is 1.5 meter, HG is 1.5 meter, GF is 1.5 meter, FG is 1.5 meter and ED is 4 meter. As we know, the force at the point G and F is 6 kilonewton. Okay. From this, based on the question, we must indicate all zero force member. Okay. How we indicate the all zero force member? Okay, the rule how to find zero force member is when they are have non-collinear, and if 3 member from a truss joined for 2 member are collinear, they are no external load or reaction joint, and the third non-collinear member is a zero force member. So that we know AB, BC, CD, DE, HI and GI is a zero force member. Okay, and the next step is we must to find the tension and compression for the force in member JE and GF. So next step we must to sketch FBD. So we know that JE and GF, JE, GF at this part, right? So we know about this part and we focus at this part as our FBD, so that we cut it at this part and we know GF is 1.5 meter and FE is 1.5 meter. From this we know force at GF is equal to force at FE. Okay. As we know trigonometry, this 3, right? So this 4 and the hypotenuse is 5. 3, 4, 5. And this FJ is the arrow is downward, and this arrow for FGF and FFE is the left side. So from this we must to search 3 terms. Is first is moment, second is summation of x and y. So for search for solve for the moment, we know that the moment is anti-clockwise, so we know it positive. So EY times 6 minus at point F negative, because the arrow is go clockwise, minus 6 because we have load, their load is 6 kilonewton, and times 4.5. 4.5 is come from 1.5 plus 1.5 plus 1.5, that's why we get 4.5, and minus at the point G because it clockwise, 6 because it have a load 6 kilonewton times 3 because 1.5 plus 1.5 is 1.5, so equal to 0. So that we solve for the moment FE. So EY times 6 equal to 45. So we know that EY is 7.5 kilonewton. So we get the moment at the point E. So that we solve for the submission for the FY and FS. So FY we know we have no value of EY, right? So we just put 7.5 kilonewton, so minus 4.5, minus because we go the FBD. So FJE, we know it downward, right? So it compressed, so we know it negative 4.5 because this Y, this X, so 4 over 5 FJE, this downward, so negative, equal to 0. So from this we know that FJE is 9.375 kilonewton. Its compression, because compression is negative from the FBD, we know that its compression at FJE. So after we get submission of Fy, we solve for the summation of Fx equal to 0. So 3 over 5, because from this 3 over 5 FJE we have know from the summation of Fy is 9.375 kilonewton. So just we put it and minus FGF. FGF, as we know, FGF, the error go at the left side, right? So it negative, and FGF equal to FFE. So GF is negative. So we solve for FGF, we borrow it at there, and we get the value of FGF is 5.62 kilonewton. It's tension because it's positive value. Thank you.
Question 8.43. The question is, the uniform rod has a mass of 10 kg and rests on the inside of the smooth ring at B and on the ground at A. If the rod is on the verge of slipping, determine the coefficients of the state friction between the rod and the ground. So here is the diagram for this question. You are given here point A, point B, and point C. The distance from point A to point C is 0.5 meter. The distance from point B to the ground is 0.2 meter. Here is the theta, 30 degree between the rod and the ground. So let's proceed to the free body diagram of this question. So as the question asks us to determine the coefficients of the state friction between the rod and the ground, so here is the rod and here is the ground. Here is 30 degree theta, same as this, and here is external load at point A, which upward error, and here is 0.4, which is we get by using this equation, sine 30 over 0.2 is equal to sine 90 over x, so x we get 0.4. So here 0.4 meter. Here is external load of point B, and here is 30 degree theta, same as this, using Z rule. Here we are given 10 kilogram, and we have to multiply by 9.81, which is the gravity number, and we get 98.1 Newton. So here 0.25 is 0.5 by 2 divided by 2, because here we are given the weight, so we have to divide it, the distance from point A to C by 2, so we get 0.25. Let's proceed to the problem solving. So by using all this information given, we can find the moment at point A, which is we assume the moment at point A is counterclockwise, which is positive. So moment at point A is equal to 0, which is start from here. External load B at point B, multiply by 0.4 minus counterclockwise 98.1 Newton, multiply by 0.25 cos 30 is equal to 0. So we get external load at point B, which is 53.10 Newton. So let's proceed to the summations of Fy. Summation of Fy is equal to 0. External load at point A plus external load at point B cos theta, which is 30 degree, minus by the weight, which is 98.1 Newton, is equal to 0. So we get the external load at point A is 52.11 Newton. So the last one is summations of Fx is equal to 0. Summations of Fx is, start from here, is force A plus external load at point B sine theta is equal to 0, which is force at point A is represent the coefficients of the state friction between the rod and the ground, and have to be multiplied with the n external load at point A, which is 52.11 Newton, plus external load of point B, which is 53.10, sin 30 is equal to 0. So we get the coefficients of the state friction between the road and the ground is 0.509.